Okay, so today we're going to talk about 3-2 and 3-3 word problems over substitution and elimination. We've been solving these with our notes a little bit, but now we're going to move a little bit deeper into it so you guys can actually get some practice. You are actually going to be writing the equations. So a couple of things I want you to remember is that you have to first pick what your two variables are going to be about. So your question to yourself is, what should my variables represent? All right. So what is the entire problem about? Okay. That's what you're asking yourself. And it should be two main things. So you should have like your X and your Y or whatever variables you choose to use. And then the other thing would be that when you're doing these, most of the time there's going to be two types of equations. There's always going to be two, but there's going to be two types of equations. And one of them is usually about the amount of items that are in the problem, okay? And then the second one is usually all about money. Now, this isn't all the time, but generally speaking, those will be the two types that you'll be looking for, okay? So for this first one, a total of 1,096 people attended the concert at the county fair. Reserved seats cost $25 each, and unreserved seats cost $20 each. If $26,170 was collected, how many of each ticket were sold? So the question at the end there kind of tells you what the whole thing is about. How many of each ticket, right? So our two things are going to be unreserved and reserved. Okay. And so if you want, you can pick X and Y. I'm probably going to just pick R and U. And then we're going to make our two equations. So if a total of 1,096 people were there, we know the first one's going to equal 1,096, right? We don't know how many of each type of ticket there were, but we know there were some unreserved and there were some reserved, and together they made that many people. So for those two, it's just our variables. The second one then is about your money. So reserved tickets cost $25 each and unreserved cost 20. So I've got 20U plus 25R equals a total of, $26,170. Okay, so again, here's one about the amount of items, and here's another one about the total amount of money. Okay, now you can tell that neither one of these are solved for a variable. So in order to solve these, we're going to have to do elimination. I'm going to multiply by 20. Sorry, I think I'll change that. I'm going to multiply by 25 to get rid of my r's so that I can make that one a negative. Okay. So I'm going to start by distributing. So I've got negative 25u minus 25r equals, and then my last part there will be negative 27,400. I'm going to make a giant addition problem. This will give me negative 5u. These are gone, and I've got negative 1,230. Divide by 5 on negative 5 on both sides, and u equals 246, which means there are 246 unreserved tickets. Okay? Well, if there's 246 unreserved and 1,096 reserved, we can take 1,096 minus 246, and that equals 850, which means there are 850 reserved tickets. And there would be our answer. We solve for X and Y, or R and U in this case. Okay, so making two of them and then using substitution or elimination to figure out what the variables are equal to. Here's our next one. Laura has $4.50 in dimes and quarters. She has 3 more dimes than quarters. How many of each kind of coin does she have? So each kind of coin tells us that it's about dimes and quarters. Okay, so I'm going to call dimes D and quarters Q. We know she has $4.50, so it equals $4.50. And we don't know how many of each one. We do know how much each one is worth. So if I put 0.10D, 10 cents for a dime, plus 25 cents for each quarter, that's going to give us our total of $4.50. So these are going to come up quite a bit, where they won't tell you the value of those, but you know the value of a dime and a quarter and a nickel and a penny. So make sure you're paying attention to that. That'll be your money one every time. And then she has 3 more dimes than quarters. So if I take quarters and I add 3 to it, you're going to have the total number of dimes. 3 more dimes than quarters. Okay? This is obviously going to be substitution because it's equal to D. So I'm going to circle the Q point, or Q plus 3, and I'm going to put it right in here for D. Okay? So I have 0.10 times Q plus 3 plus 0.25Q equals $4.50. Let's distribute. So 0.10Q plus 30 cents plus 25Q equals $4.50. Combine like terms for these two gives me 35 cents Q plus 30 cents equals $4.50. Subtract my 30 cents here. This is 35 cents Q equals $4.20. And if I divide by my 35 cents, I get that Q equals 12. So there are 12 quarters in Laura's money, and she has 3 more dimes than quarters. So that would be 15 dimes. Okay, excellent. All right, let's go to the next one. We have the rectangle has a perimeter of 56 feet, and its length is 8 more than its width. Find the length and width. So again, that last sentence kind of tells you exactly what, the whole thing is about, which is length and width. Okay, so I'm going to call my length L and my width W. The rectangle has a perimeter of 56, so it equals 56, and we get perimeter by taking twice the width plus twice the length. Okay? Then the length equals 8 more, so 8 plus the width, so 8 plus W. Okay? Again, this one is already solved for a variable, so I'm going to circle this part and plug it in for L, which gives me 2W plus 2. Substitute in 8 plus W equals 56. Distribute here gives me 2W plus, 16 plus 2W equals 56. Combine like terms is 4W plus 16 equals 56. Subtract 16, 4W equals 40. Divide by 4, and W equals 10. So the width is 10 feet. The length is 8 more than that, so that makes the length 18 feet. There we go. Okay, last one. We have 3 times the first number minus 2 times the second number is 27. 2 times the first number plus 5 times the second number is -1. Find the two numbers. So the two numbers is what we're looking for. X and Y. The first number and the second number. Okay, so we're literally just going to write out exactly what it says. 3 times the first number. So 3 times the first number, which is X, minus 2 times the second number. So 2 times Y, which is our second number, means equals 27. There's your first equation. Same thing with the next one. 2 times the first number, so 2x, plus 5 times the second number, which is y, is -1. Okay, so This is going to be elimination again because we don't have an equation set equal to a variable. I'm going to get rid of x's by making this guy positive 6 and this one negative 6. So let's distribute. I have 6x minus 4y equals 54. Then negative 6x minus 15y equals 3. Big addition problem. These are gone. Negative 19y equals 57. Divide by negative 19, and y equals negative 3. So there's my y. Now let's plug it back in and figure out x. So, 3x minus 2 times negative 3 equals 27. So 3x plus 6 equals 27. Subtract 6. 3x equals 21. Divide by 3, and x equals 7. So my ordered pair would be 7, negative 3. First number, second number. Okay, so read through these carefully. Think about what your two variables are going to be. You're going to write two equations, usually one about items and one about money. If not, then they're just going to be different types of equations. Some will be substitution, some will be elimination. It just depends on the type of problem. So what I'm going to do for this homework section is you guys are going to do these next 4. I'm going to go ahead and give you the answers, but you have to show all the work to get there. But this way you can kind of see if you did it correctly without me doing it for you, okay? So there's your first one. Your second one is Carl worked 12 hours and Ryan worked 16. Your third one is 21 and 15. And the last one is 27 quarters and 8 nickels. Okay, so give this a try, see how it goes. Let me know if you have any trouble, and we'll talk about the answers and work out any we need to in class.